Hi, welcome to my video on proofs with parallel lines, part 1. Just doing a review of the different types of angles with parallel lines. Proofs with parallel lines, part 1. A transversal is a line that intersects two other lines. We have a line ML and AB is cutting those two lines, so AB intersects the lines M and L, and this AB is a transversal. Transversal is a line that cuts or intersects two other lines. Parallel lines are two lines that never intersect. They are the same distance, perpendicular distance apart. So we say the same distance apart, we mean the perpendicular distance. So here's two lines A and B. MF is perpendicular to B. TV is perpendicular to B. So AB is parallel to A, and B are parallel to each other by the marks in this statement right here. And we're saying that MF is perpendicular to FV by this mark. TV is perpendicular to FV by this angle marked. That means that MF equals TV. The perpendicular distance between the parallel lines are equal. Here we have a diagram with 8 angles named. T is indicating the transversal cutting through two lines A and B. T is the transversal. Now we have many types of angles when we have a transversal cutting a pair of lines. The interior angles are inside the lines A and B. The interior angles are inside the lines A and B. The interior angles are 4, 3, 5, and 6. 4, 3, 5, and 6 are the interior angles. The exterior angles are outside the lines A and B. The exterior angles are outside the lines A and B. So it's 1, 2, 7, and 8. 1, 2, 7, and 8 are the exterior angles. The corresponding angles are two angles, non-adjacent on the same side the transversal. One is exterior and one is interior. Their corresponding angles are non-adjacent, like 1 and 4 are adjacent, 2 and 3 are adjacent, 6 and 7 are adjacent, 5 and 8 are adjacent, 5 and 6 are adjacent, but they're non-adjacent. One is exterior and one is interior. So corresponding angles is 1 and 5, 2 and 6, 4 and 8, 3 and 7. 1 and 5 are corresponding angles, and they're on the same side. They're on the same side the transversal. That's exterior, that's interior. 4 and 8 are corresponding. This one is exterior, this one is interior on the same side. 2 and 6 are corresponding angles. This is exterior, this one is interior on the same side the transversal. And 3 and 7 are corresponding angles. One is interior, this one is exterior. Alternate interior angles are two angles non-adjacent, interior on opposite side of the transversal. They form a Z. Notice alternate interior. Let me explain. Alternate interior are interior angles on opposite sides of the transversal. So these are 3, 4, 5, and 6 are interior, but they're opposite interior. So 3 and 5 are alternate interior. Alternate means move across the transversal. 4 and 6 are alternate interior, moving across the transversal. And another pair of angles is alternate exterior. Two angles, non-adjacent, exterior on opposite sides of the transversal. Opposite sides of the transversal. So the exterior angles are 1, 2, 7, and 8, and they alternate. So 2 and 8 are alternate exterior. 1 and 7 are alternate exterior. And also, same side interior angle pairs are 4 and 5, 3 and 6. All same side interior. So these are the interior angles, 3, 4, 5, and 6, but they're the same side of the transversal. So they're interior angles on the same side, 4 and 5. 3 and 6 are interior angles on the same side, the transversal. And another pairs of angles is what we call the vertically opposite pairs. Vertically opposite angle pairs, and that's 1 and 3 are vertically opposite across from each other. 2 and 4 are vertically opposite across from each other. 5 and 7 are vertically opposite angles across from each other. And 6 and 8. So they're formed by intersecting lines across the vertex, opposite of each other. So again, 5 and 7, 6 and 8, 1 and 3, 2 and 4 are vertically opposite angles. So that's the type of angles that we're going to use when we do proofs with parallel lines. Let's do some more practice. And we have, just move this down a tiny bit. We have section A, we have two lines E and F being cut by a transversal, and we have all these angles. A is a transversal cutting through E and F. And we're going to name all the pairs of each that are from the above diagram. The corresponding angles in this diagram, corresponding angles are on the same side, one exterior and interior. So angle 2 and angle 3 are corresponding. 4 and 5 are corresponding. 8 and 1 are corresponding. And 6 and 7 are corresponding. Notice corresponding angles are on the same side to transversal. One is exterior, one is interior. Alternate interior are interior angles across each other. So it could 4 and 1, 3 and 6. So angle 4 and angle 1, and angle 3 and angle 6. And there's no more. Alternate exterior are across the transversal exterior angles. So it's 2 and 7, 5 and 8. 2 and 7 are alternate exterior, 5 and 8 are alternate exterior, and there's no more pairs. Same side interior angles would be, same interior angles on the same side would be 3 and 4, and 1 and 6. And there's no other pairs. And vertically opposite angles, 2 and 6, 4 and 8, and down here 1 and 5, vertically opposite angles, angle 5 and angle 1, 3 and 7, angle 3 and angle 7 are vertically opposite angles across the vertex when two lines intersect. B, we have a diagram. It says F is the transversal cutting through the lines A and B. And it says name each from the diagram B. In B, alternate interior angle to angle 4. Here's angle 4. Alternate interior would be 3. Angle 3. Number 2, corresponding angle to 1. A corresponding angle on the same side of transversal. That's exterior. It must be angle 3. 3 is interior. Same side interior angle to 6. There's 6, same side interior angle would be 4. Alternate exterior to angle 2. Alternate exterior angle across the transversal would be 5. Vertically opposite angle to 5, across the vertex would be angle 6. Across from angle 6. C, again we have a transversal cutting through these two lines. T is a transversal. Name each in this diagram. An angle adjacent and interior to 2. Adjacent to 2 and interior. So there's interior and adjacent. So this is alternate. So it's adjacent, which is alongside of, and so it's angle 3. An angle exterior and on the same side as angle 4. There's angle 4. It has to be an exterior angle on the same side. So an exterior angle on the same side would be angle 1. Is exterior angles on the same side, not on opposite side, not alternate. Two angles non-adjacent interior to 5. Two angles non-adjacent interior to 5. So it's not allowed to be adjacent. So adjacent would be 6. So two angles that are interior on interior non-adjacent. So it's angle 2 and angle 3 because angle 6 is adjacent. These are 2, 3, 5, and 6 are interior, but 6 is adjacent to it. Adjacent angles have common arm and no overlapping. So these are non-adjacent to 5. D. Correct each statement using both angles. Use the diagram in C. Use this diagram here. Angle 1 is corresponding to 8. Angle 1 is corresponding to 8? No. Angle 1 and angle 8 are alternate exterior. They're alternate exterior angles. 1 and 8 are not corresponding, they're alternate exterior. 3 and 6 are alternate exterior. 3 and 6 are not alternate exterior. They're interior angles, so they're alternate interior. Notice I write ALT for alternate, INT for interior, just to save some time and save some space. Okay, let's continue. And now we have, a diagram. Here we go. We have a diagram that, move it down a bit so we can see it. There it is. We have a diagram, two lines A and B with T as a transversal, and it says that A is parallel to B. A is parallel to B given here, so I can put two of these arrows on it. These arrows indicates that they're parallel to each other. A is parallel to B. And we have some statements. If a transversal intersects a pair of parallel lines, so if this transversal intersects these two parallel lines, then the corresponding angles are equal. 1 is equal to 2. Also, the alternate interior angles are equal. 2 is equal to 3. Also, the alternate exterior angles, 1 is equal to 4. And the same side interior angles, these are angles on the same side interior, they're supplementary. So 3 and 5 are supplementary. So these are statements that when you have parallel lines, you have corresponding angles equal, alternate interior angles equal, alternate exterior angles are equal when the lines are parallel cut by transversal, and the same side interior angles are supplementary. So, based on that, I call PLT is parallel line theorem. So to use A to D, to use the four of these above as a reason and a proof, to make a reason short, I named them as. So if instead of writing out the whole statement, if a transversal intersects a pair of parallel lines, then the corresponding angles are equal. So I just write, instead of making this full statement here, I just go PLT, corresponding angles equal. Saves all this writing. Or instead of saying if a transversal intersects a pair of parallel lines and the alternate interior angles are equal, I go PLT, which is parallel line theorem, and say alternate interior angles equal. Or if a transversal intersects a pair of parallel lines, then the alternate exterior angles are equal. So I just say PLT, alternate exterior angles equal. Again, saves this long worded sentence. And if the transversal intersects a pair of parallel lines, then the same side interior angles are supplementary. Again, say PLT, same side interior angle supplementary. So I use that statement. So here we go. So what we have, let's do some examples. Here, number 1, I'm given that A is parallel to B. So if A is parallel to B, and that's the given, then angle 2 is equal to angle 3. Why? PLT and their corresponding angles. Corresponding angles equal. So instead of saying if a transversal intersects a pair of parallel lines, then the corresponding angles are equal, I'll just go PLT corresponding angles equal. Number 2, AB is, if you have AB is equal, parallel to PQ, and that's a given, then we have angle 4 equals angle 7. And angle 4 and angle 7 are, what's the reason? PLT. And we have alternate ALT, interior INT, angles equal. Again, PLT makes this long statement if a transversal intersects a pair of parallel lines. But check with your teacher on using these. Check with your teacher. And number 3, we have a diagram here, and we're given that XY is parallel to VW. So that's a given. So if that's a given, what can we say? Well, we have many. We can say that 1 equals 3. 1 is equal to 3. That's a PLT. And 1 and 3 are corresponding angles. Corresponding angles are equal. We also have that 1 equals 4. We can also say that angle 1 equals angle 4. 1 and 4 are PLT, alternate exterior angles equal. PLT, alternate exterior angles equal. And we could also say that because of the parallel lines, we could say that angle 2 is supplementary to angle 3. And the reason is PLT, and that's the same side interior angles are supplementary. Again, PLT makes the statement shorter. We also have another pair of angles equal, but they're not because of the parallel lines. We also got 3 is equal to 4, but it's by vertically opposite angles, not because of the parallel lines. So we could say also that 3 is equal to 4, but it's VOAT, vertically opposite angle theorem, or VAT. Check with your teacher, vertical angle theorem. But these angles are not equal because of the parallel lines. These two angles, 3 and 4, are equal because the lines are intersecting. This line intersects, or this segment or line intersects with this one. And also, if a proof has parallel lines in the given, then the proof will probably use one or more of A to D above. So if you're given a pair of parallel lines, you will probably have one or more of these in your proof. So that brings us to the end of those statements and identifying, alternate interior, alternate exterior, corresponding or vertically opposite angles equal. Get you used to, when you're given a pair of parallel lines, you will have one of those statements guaranteed in your proof. And if you like my video, click the like button, subscribe button, notification bell. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.